Hello and welcome to Algebra 2 CST release question number 53. Here's what we got. It says, what is the solution to the equation 5 to the x power equals 17? And notice no calculators allowed. We're not just typing something like this in to a calculator and figuring out what it is. We have to get it in terms of logarithms here. I can eliminate choice A really quickly because if I plug in a 2 right there, is 5 squared equal to 17? Clearly not. So that one I'm going to get rid of, but I'm going to need some room to work over here. I want to first just kind of introduce you or reintroduce you, help you review what logarithms are in the first place and how are we going to get an answer that looks like one of these things. So logarithms in general, you have something that looks like this. So in general, what I'm talking about at first here, it's going to be in this form where you have log, and I'm going to write a lowercase b, that's a subscript, so it's lower, written lower than the actual letters there. Log base b of some number, we'll call it n, equals k. So this works if and only if, so this works in both directions. If this is true, this is going to be true. If this is true over here, then this is going to be true over here. This only works if this is the case, that base to the power equals the number. I want you to think of this, it's kind of going around in a circle. So here's your base to this power equals this number. So the base to the power equals the number. Think of it as a circle kind of closing itself off. The base to this power equals that number. That helps me a lot, and I hope that it helps you a lot too. And so that's what we have going on here. The base is 5. The number itself, what it's equal to, is 17. So the base to the x power is this number. So another way to write that in particular for this problem now becomes the log base 5 to the, or of the number 17 equals x. We're trying to solve for x. We're trying to get what that particular number equals. Now, since calculators aren't allowed on the CSTs, and since we need to know how to do this without a calculator as it is, and since we notice there's this log base 10s over here, this really isn't the way we want to tackle this problem. This is true. It's a true statement based on what I have up here and talking about it in general. If this is true, 5 to the x power equals 17, then that means log base 5 of 17 equals that x power. That's true. So this is true, but again, not helping us solve the question, so it's just kind of like an aside or just a nice thing to know. But we can also take this and we can apply some laws of logarithms. I can, just like I can take something, divide it by 5, or I can take something and subtract 5 from both sides of the equation, and I still keep it balanced. If I take the log of both sides, the logarithm of both sides, it still keeps it balanced. I've got log of 5 to the x equals log 17. And so remember, when you don't write something in here, I'm going to use orange for this, but it's like you're putting an invisible 10 right there. If you don't write an actual number after the log, it's always assumed that it's log base 10 of that particular value. And in general, we have some laws of logarithms that help us determine how to solve this problem to the end here. So laws of logarithms, I can't spell, boy. Logarithms, gotta insert that in there, logarithms, there we go. So the laws of logarithms, what are they? There's 3, one of them will be used here, potentially more than one, I guess, but we know that log, if you take a log with any base, and you have two numbers multiplied together, we'll call them m and n, this is the same thing as log of that same base of one number plus the log of the same base and the other number. Another thing that works out, another law of logarithms, we're not proving why these are true right now, we're just kind of utilizing them. But we have something like this with division of two values with a base of b. We can take the 1 on the top, the numerator, and subtract the log base b of the denominator. And then finally, the 1, which is going to be actually helpful here, if you have something like this where you have log base b of some number, we'll call it m, to some value k, this is equivalent to saying k times log of that, whatever that base is, we'll call it b of m. And so I see that applying right here. I can write x out here, this using law number 3. This is the same thing as I've got my m is 5, my k is x, and my b is base 10. And so I'm gonna write base 10 in here since our final answer has that in there. So this is equivalent to saying x times log base 10 of 5 is equal to log base 10 of 17. From there, log base 10 of 5, that's just a value. It's just a numeric value. You could get that by typing it into a calculator. You can just type in log 5 and it would tell you what that is exactly. And so really this is just some decimal times some number x. So it's maybe whatever point whatever times x. We're dividing by, or we can divide by, that value since it's just a decimal number, and do that on both sides of the equation. And just as if this were a coefficient, it would cancel out in the same manner. And so we have our final answer is what's left over, log base 10 of 17 divided by log base 10 of 5. We're not required to figure out what that actually equals as an approximation. It should be somewhere in between 1 and 2 because 5 to the first power is 5 and 5 to the second power is 25. But again, we don't need to actually figure that out here. It would require the use of a calculator or some logarithmic tables, which we don't have. But our final answer, choice D, is the correct choice here for number 53.